Good morning. In this opportunity, I am going to present this article. The title is Automatization of Hydrogen Production and Automatic Filing Control. The review is EEE World 8 IoT Congress. In the abstract, according to the Ministry of Energy and Mine, this is about the energy production and the automatization of hydrogen production and automatic filing control, the simulation, design, hydrogen plant, and the software used in this case is FlexSim, and other methodologies and velocity mapping, the factory IoT and the portal software will uses the obtain the filing control, in which is optimal for this process, and run speed for the units of produced and ROE units in other lines of production. About the introduction, is for that for this content use hydrogen, because this is a clean and an environmentally friendly energy vectors. Is different use in other sectors, in mining, in industrial sector, in others. This is important, the production of hydrogen about the energy renewable. For implementation, material and methods of FlexSim. It is a software development by American FlexSim company, with insert into FlexSim the C++, IDE, and compiler in a modeling environment. Another consideration is versatility for the study of technological systems of different stages of the product life cycle. About the materials and methods, CISO 901 quality management. The organization must establish, implement, maintain, and continuously improve a quality management system, include the necessary process and their interactions in the process. Figure 2. The first is a hydrolysis in the first tank, and the second tank but hydrolysis, and the suministry is the photovoltaic energy, with the separation the oxygen and hydrogen, with the packing and storage the finished product. Materials and methods, but this plan designed, and this is the plan, the layout for the plan design, with equipment such as machinery, equipment, furniture, within an organization was allocated to have the fastest material flow. Also, that's overall operating cost and minimized. In this part, this is the process of production of hydrogen, and the input and the final materials of final product. Electrolysis process. The electrolysis of water is a process by which hydrogen and oxygen are separated, passing an electric current out. It is a process forced by the passage of electric current. In this part, with a wind solar power source, is the subministry in for the process of the cathode and anode, you obtain the separation. FlexSim hydrogen production plant, and this methodology is value stream mapping. In this action, there's capture both the value out in the visual for the process in material in this part, and the first and the second is the sequential plans that avoid obtain the raw material, and transformation process that's made with the electrolyzer, which allows separating the oxygen and hydrogen in the total cycle time. Flowchart. First, to establish the development of the process. This is essential for about the simulation with run and data. The flowchart. Does the system start? A question and the process in the sequential. Connection between factory I/O and TIA portal. In Figure 8 shows the implementation of the system and simulated approach, which is the controllers uses in the factory I/O software are shown of the sensors and actuators in the fuzzy sensor robotics arm in the simulator of the filling gas cylinder. Connection between factory. In this part, where in the first row in the system, on another hand, it consists of two cylinders, where is simulated that the cylinder is storing hydrogen and other oxygen. Where you can see the control of filling the gas cylinders as shown in Figure 10. The materials and methods. This is about the standard allows for strategic manufacturing and product development planning. The guides have specific methods or mechanisms to be used living and deduction approach, given better cost estimate and the project and definition. The methodology is covered for phases modeling, prototyping, and simulation. About the result, 8 FlexSim software simulation. This is a plant of process in the plane of FlexSim process. The production, which begin with a reception of distilled waters, then passes to the fluid tank for temporary storage. The process that follows is to separate the water molecules by means of the electrolysis with the separation of hydrogen and oxygen. In generator, this releases the oxygen. This is the general 2. Hydrogen is concentrated for packing. It passes to conveyor, then process with packing and storage. The result running in FlexSim. This is the result in a 1 to 10 run speed. This is the time course and the hydrogen balloon produced, and units hydrogen produced and 66.667 run speed, 250. This is the hydrogen balloons produced in the graphic within. Simulation of the portal and factory I/O programs. This is the ignition of the system where the box simulation, where it simulation conditions for the balloons shows. In the time of 10 seconds, the balloon is filled and the conveyor belt activated where it's sent to a warehouse. A simulation with the factory I/O environment, where the box can be visualized in case of accumulation or unforeseen failures. The process is stopped. Discussion in the work of the Rugo A. Merritt, some out and others authors, they development an electrolysis mechanics that's the powered by wind and solar energy that's only resources electricity consumption, but the process of obtaining green hydrogen energy is not automatic, which only leads to an efficiency of 22.15 voltage. In this research, the hydrogen production and automatic filling control was simulated using FlexSim and value stream mapping to improve the production process, while the state of the filling transport of the hydrogen balloons uses factory I/O and the portal software. In conclusion, the analytics performance in FlexSim software allowed is established in the plant layout, and together with the value stream mapping that determined to eliminate unnecessary production process, having a total cycle time of 28,710 seconds. The time is 137 seconds hydrogen values. So in the production of hydrogen, that's the simulation performance was obtained in 12 minutes with 3 seconds. This is the conclusion. Another is because the value with the portal software you need, and the design of plant in FlexSim. Another is the conditions is the condition in the program. It has implemented an emergency system is a control box in case unforeseen happens with the system or any emergency. This is important. You design of plant and the process of hydrogen with these methodologies. Thank you so much.